on Tuesday next week? Okay. Have you looked far enough ahead? Do you know that next Wednesday is what? On what lesson? 1-1 to 1-4. Okay. All right. All right. Ready? Read this. All right. Let's read it together. This is supposed to be a worksheet you were going to do in your group and read the book, but we're just going to kind of fly through it. Here we go. After reading lesson 1-4, discuss each of the questions below with your group and answer them as completely as possible. This should serve as your notes and reminders for completing the assignment. Now, we have notes. I gave them to you, but we probably won't do them all next Monday because a lot of this is Monday's notes, okay? We're not going to read it in groups and answer them by yourself. We're going to do it together, okay? So here's number 1. What are the 4 characteristics that make a relation a function? Think about what you're writing. Don't simply copy the information from your book. Here, it's on page 39. So if you open your book to page 39, you'll see the 4 characteristics of a function. Okay? First of all, it does say there's 4 characteristics of a function. The word relation, do you know what that means? Because it says 4 characteristics that make a relation a function. Anybody know what a relation is?
Two quantities are related to each other, but yeah.
This is order pairs. So 2, 6, 4, 1, 9, 3. That's a relation. Now, what makes it a function? Okay. Now they say read it and then copy what it says, but it doesn't say copy. Put it in your own words. So the very first thing it says is what? Each element in set A must be matched with the element in B. Did it say match with an element? So I go back. I want to go to this. They call this A. They call this B. Okay. I don't really call it A, B. I call it XY. You can call it XY, but I call it input. What? Output. Okay. Then I say, let's talk about XY. Well, X's are your input. Y's are your output. So the first thing it said to you was each element in A gets what?
1.
Yeah, an element in B. And it says an element. It doesn't say 2 or 3, it says just 1. So that would be like the first thing you'd want to write to yourself. What's a function? Each, and I'm going to say it this way. I'd say each input, what do you think? Gets how many?
1 output.
Yeah, say 1. Gets exactly 1 output. Okay. All right. The second characteristic in that box says some elements in B may not be matched with any elements in A. Let's go back to this. This is like a function. Here's your X's. This is the time of the day. 9 a.m., 10 a.m., 11 a.m. That's the temperature. So 9 a.m. What's the temperature?
50 degrees.
Okay, 10 it's 63. So each element's getting 1 answer. That's what we just said. But the second characteristic says some of the outputs what?
Okay.
Yeah, 58 and 78. Oh no, 58 and 62. They didn't get anything, did they? They didn't get matched up. So how do we want to say that? Somewhat.
Outputs don't get.
Okay. All right. Some outputs don't get inputs. So not all the Y's get matched up with X's. Okay, does that make sense?
Yeah.
All right. Next, 3. 2 or more elements in A may be matched with the same element in B. How do you want to say that? 2 or more inputs, what?
They share an output.
They can share, okay. Can share an output.
Yeah.
Okay, so what that means to you, I hope, is 2 could get 5, 3 could get 5, 5 could get 5. So the y value can show up many, many times, right? All right. Did 2 get exactly 1 answer?
Yeah.
Did 3 get exactly 1?
Yeah.
Did 5 get exactly 1? Yeah, that's what the first thing said. Each input gets exactly 1 output. Keep looking at this, it kind of makes sense. Last characteristic says, an element in box A, inputs, domain, cannot be matched with 2 different elements in B. So, is this true? Can you do this? Can it do this? Can at 9 a.m. can it be this temperature? And then can 9 a.m. be this temperature? They can't be 2 different, right, temperatures? So, what do you want to say on that one?
One input can correspond to multiple outputs.
One input can't be what?
Correspond to multiple outputs.
Correspond to multiple. I don't want to spell that. Okay. I just wrote each input must be paired with an output. That's all I wrote. That's all I wrote. Yeah, that's it. Okay. So if this happened, watch this. 2 gets 6, 2 gets 10. What do you think? Not a function. They're going to ask you this in your book. They're going to go, is it a function? Is it not a function? All you got to do is look at the x values. If you see 2 happen twice, it better get 2 gets 6, 2 gets 6. Didn't happen, guys. So you'd say what to this one? Not a function. Okay? It's a relation, it's ordered pairs, but it's not a function. Okay? All right. That first question was just a bunch of like talk. What is a function? What you need to think in your head is each x value gets exactly what? 1 y value. Inputs get only 1 output. Okay. Number 2, here we go. There are 4 ways that we will represent a function. Translate the following algebraic description into each of the other 3. So here's an algebraic way of saying, here's your function, and that is, just write yourself a what? An equation. That's a function, guys, right there. But you can do it verbally, you can do it numerically, and you can do it graphically. Okay, so verbally, what is that telling you? What is that? I mean, can you use your words? Can you write it out?
Input squared is the output.
Louder.
If you square the input, you get the output.
If you square the input, you get the output. How's that? Which one's the input? X. If you square the input, you get the output. Sounds good to me. There's many ways to say it. I didn't say it that way, but I'll write his way. Squaring the input gets the output. Got it. Okay, numerically, that just means make a table. Make a table. Okay, let's do that. It says up here y equals x squared if x is an integer between 1 to 10. So if I graph any of those points, 1 to 10, let's do 0, let's do 1, 2, 3, that's probably good enough. What do you think? If 1 goes in, or sorry, if 0 goes in, what's the answer?
0.
1 goes in, 2 goes in, 3 goes in. Okay. So you can numerically look at a function. It's a table. It's kind of telling you where to go. And then C would be graph it. Well, if I graph these ordered pairs, 0, 0, 1, 1, 2, 4, and 3, 3, 9. If I connect them, it looks like this. If I would have tried negatives, do you know what would have happened? It would have been a parabola. You would have basically just shot up this way, okay? If I would have graphed those ones, okay? All right. So you can, when looking at a function, you can do it algebraically, write the equation. Verbally, just say what it says. Numerically, table, graph it, and graph it. Okay? Part 3, question 3 says, in the function described as y equals f of x equals x, no it doesn't, 2x minus 4, they're trying to tell you this. The letter y back in 9th grade, or whatever grade, the letter y is replaced now with what? F of x. How about replaced by this? And that's called f of x, right? That's how you say it. All right, so now, if I cover this up, you have to think of f of x as what? Which is y. That's all it is. So f of x is equal to y, all right? X is called the blank variable, y is called the blank variable. So what is x called?
Independent.
Yes. And the reason they call it independent is because
That's what you put in.
you have all the freedom in the world to put whatever you want in. 0, 3, 5, 10, put whatever you want in. So whatever you put in for x, then the y value is called the dependent. Y kind of depends on whatever you put in for x. So y is the dependent variable. X is the independent variable. Okay? Okay, now please follow this. F is the blank of the function. F is the name of the function. And F is just a very common letter they use, F of x. Why do they use F?
Function.
Sounds nice.
Function.
Well, it's a function. F, function starts with F. Now, if I was talking about the cost of a company, I'd probably go C of x. Profit, I talk about P of x, okay? So you use whatever letter you want to use. Name it, just name it. I'm naming it F, okay? F of x is what? F of x is the
Function in terms of x.
F of x is the y value. So if you get f of x to be 7, you know what you found? You found the y value, okay? Of the function at, it says of the function, and I'm supposed to put at what? X. So what I'm trying to say is this. If you put in 7 and you get out 10, well, 7 goes in and f of x is your y value, 10 comes out. I'll talk more about this on the next page. That probably got a little confusing. Okay, next page. All right, when evaluating a function for specific values, we substitute that value in for x, or whatever variable we're using, and simplify the expression. So here comes your first function, f of x equals, is it just this?
Yeah.
Yeah, okay. Now remember, f of x was really just what letter? Y. So we just don't write it, even though it is written there for you. Okay? Now, ready? Your first problem is f of 4. Now, what that means is take your function f. And by the way, where's your function? It's x minus 3. It's right here. This is the function. Now, you're supposed to take that and evaluate it when x is what? 4. Answer 1. Now, hang on. You got to get this in your head. The function, the f of 4 means this. What's the value of your function when x is 4? And the answer is 1. So what you really just found, everybody, what'd you find? You found the y value. You chose 4 for x. You found the y. You found an x and a y. You found a point. You guys, you just got yourself, whoa, I messed up already. You just got yourself a point. It is what? 4 goes in and 1 comes out. That's what it means. Okay? All right, do the next one. And the next one is you are going to put in, not a number, an algebraic expression, 3h. Put 3h into your function. See what happens. So in for x, you put what? 3h. Then you subtract 3 from 3h. What do I do? Can I take a 3h and subtract a 3? Are those like terms? So what do? Leave it. It's the answer. No, I'm not asking you to solve anything. I'm just saying simplify this expression. Can you? Can we simplify this? No, we're done. What's the answer to f of 3h? 3h minus 3. Okay. See, you guys want to see numbers. You want the answer. 1, 2, 3, 4. Doesn't always come out that way. If you put an algebraic expression in, most likely you're going to get an algebraic expression out. Okay. All right. Next, f of what? X what? X plus 2. Put an x plus 2 into your function up there. And I can't see my function. So let me write it again. So what did you put into x? This number. X plus 2 goes in for x. But what's that? No, what's x followed by? Minus 3. Is there anything you can do? Yeah. Answer? X minus 1 is the answer. So what is the value of your function when you plug in x plus 2? The answer is x minus 1. It's weird because you guys are putting algebraic expressions in, which they don't give you all answers like 7, 8, 9, 10. This is your answer. Okay. Next, it says, for what value of x does f of x equal 0? 3. Okay. Here's your function, f of x equals x minus 3, right? Well, they're asking you, when will your function f of x be what? 0. When will f of x be 0? Well, put it in. Put 0 in for f of x. Solve it. What do you get? 3. Now, try to understand this. When you say this is the answer 3, you're saying when x is 3, the value of my function is what? 0. What's f of x though? Isn't f of x just y? So guess what? When x is 3, y is 0. So that means you just found what? Yeah, you just found the x-intercept. Otherwise known as? You just found a 0 of your function. You found when your function is 0. Okay. Part 5. Part 5 talks about piecewise graphs. Sometimes the rule for a function changes for different values of x. This is called a piecewise function. For each value of x below, draw an arrow to the part of the function you substituted in for. Okay? So maybe while I write this, you can do it. Just draw arrows. Show yourself where you're going with those values. When x is 3, when x is negative 3, when x is 0, where would you go? Would you go here, here, or here? And you got to remember, this column right here would be called your restrictions. You are told to use this function when x's are what?
Less than 0.
Any number less than 0, go with that function. Then use this function when you plug in what?
X equals.
If you let x be 0, go to that function. If you let x be greater than 0, go to that function. So now you know that. Draw your arrows. Where would you go with this number? Which function? Here, here, here. Where? Bottom? I hope you said bottom because isn't 3 greater than 0? So you plug it in, right? Okay. Where would you go with the negative 3? Top, because negative 3 is less than 0. Okay. And of course 0 has to go where they're telling. When x is 0, go with this function. Good? Now, just give me the answer for each one of these. Let's try it. If you did put 3 into your function, what comes out? Look, 3 goes in. 6, right? If you put negative 3 into your function, 9. If you put in 0,
1.
oh. It says right here, if you put, where do I put 0? In that function. What's there to do over there? There's no x. The answer is what? The answer is 1. 0, 1.
So just a horizontal line.
Yeah, this one is a horizontal line. Because you got to remember, this really says what? Y equals 1, horizontal. Y equals x squared, parabola. Y equals 2x, line. You know, these are piecewise graphs. You guys know piecewise graphs look something like this. Now this, remember doing this? Remember doing that stuff last year?
Yeah.
Those are piecewise. It's coming up, I think, next week. Okay? Number 6. Domain. Domain. Now, before I talk anymore, the domain will be what? Your x's. Okay, how about this? You see those last 2 letters? In. Think of input. You put in x's, you get out y's. What would the y's be called? Well, that's the range. Okay, all right, let's read. What are the 2 most common algebraic restrictions that must be placed on the domain of a function? These are the x's that you can put into your function. Almost always, guys, you can put every number in, and every number we give it a name. What's that name? When I can use any x, we call it the what group of numbers? Can't hear you. It's the largest group of numbers there is. What? I thought I heard it. Real, the real numbers. The real numbers are the domain all the time, unless something happens. And the something I'm talking about is this, or this. These 2 functions, you have to always look at those and go, oh, wait a minute. I can't put any number into this one. I can't put any number into this one. Let's go back here. What can't you take the square root of? Negatives. You can't take the square root of a negative number unless you're going to bring in what? The imaginary numbers. And we're not talking imaginary, not yet. So here you say there's a restriction here. And what I say this is in your line now, do this. The restriction will be any x values that result, I want to make sure I'm doing the right one, in even roots. Even roots of negative numbers. Okay? So, what can't you take the root of? Negative numbers. But it's not just, which root is it?
Even ones like 2.
Like square root, you can't take square root. What's another one?
Fourth.
Fourth root, sixth root, eighth root, 10th root. You can't do it. Negatives won't work. Okay. What about this one?
X can't equal -4
Why can't x be -4?
because that would put a 0 at the problem.
Okay, that would make the denominator 0. You can't divide by what?
0.
Can't divide by 0. Okay. So, when you write that restriction, you should say any, watch here, any x values that result in division by 0. Division by 0 doesn't work. Good. That's it. So when you are asked, what's the domain, you will tell me, here we go, ready? Let's go this one. Okay. What's the domain of that function, f of x? What numbers can I put in and still get answers? 4? Okay, 4 plus 5 is 9, square root of 9 is 3. You're right, but there's millions of answers. We've got to say from here, that way, forever.
X is greater than or equal to -5.
Like this?
Yep.
Okay, do you know what he did? I don't know, Noah, if you really did this, but I'm giving you credit, Noah. I'm thinking Noah said, I know 0 and up, I can take square root of. So, most likely, he did something like this. I know the number inside has to be greater than 0 or equal to 0. And then he solves it, right? And he calls that his domain. Okay, put -5 in, what do you get?
0.
What's the square root of 0? 0. Put a -4 in. 1. Square root of 1? 1. It's working. It's working. But if you put in a -6, would it work? No. So he's got all the numbers, but he forgot to say one thing. Comma. The domain is all the real numbers as long as you start with what? -5 and up. Okay? That's a good indicator of what's coming. The other one would be this one. F of x equals 2 over x plus 7.
All of those unless x is -7.
What'd you say?
All of those unless x is equal to -7.
He says all real numbers,
X
but x cannot equal what number?
-7.
Do you agree with that? I can put any number in. I can divide by any number except 0. What's the only time that's going to be 0?
That's no.
So in your mind, you could think of it like this. When is x plus 7 0? X plus 7 is 0 when x equals -7. So don't let it be -7. Yeah? Okay, that last number, number 7. Number 7, if you run into it on your assignment this weekend, don't do it. We'll wait till Monday. Oh, the implied domain is, what's the implied domain? All real numbers. And what that means is simply, we always assume anything works. The assumption for domain is everything works until you prove it doesn't. Okay, that takes care of 1 through 6, and that's good enough. Good luck on your assignment. Do the best you can. Monday, we will repeat a lot of that and maybe do number 7. Okay? How'd the quiz go? Is it okay? You went okay, guys?
Oh, how about your partner? Is it
Morgan.
what's her name?
Her name's Morgan.
Morgan Fisher.
Huh?
What's her name? Fisher.
Morgan Benson.
I just totally blanked out on her name. Okay, Morgan Benson. Morgan, did I get your quiz? Oh, okay. Yes, that's. Oh, I got a meeting for 20 minutes.
Alright, that's fine. I'll watch
First
the
20
videos.
minutes, I'll be gone.
Yeah, is the door gonna be unlocked?
You can come in here and work, but I just won't be here for
So
the.
I can still watch the video.
Oh, yeah. Okay.